Alright, so today's video is on the M-217 impact fuse. As you see from this picture, it looks pretty complicated. A lot of people see it and a lot of people mistake it for a regular grenade fuse for some reason, and it just confuses everyone. So as I said, this is an M-217 fuse. It's inside of a M26 grenade, making it an M26A2. The M26A1 was just the, as you see, all the fragmentation sleeves that are in here. They're square now. Before that, they were different. They were made differently. Anyways, so it's an M26A2 grenade. This hollow space is usually filled up with explosives. And for the person throwing it, there's no real learning curve. You pull the pin just like on a regular grenade and you hold on to that spoon until you throw it. And as you see, the pin's right there. You've got the spoon here, and when the spoon releases, this comes right across and hits that little device here, which is a primer, much like the other grenades that I showed you. The rest of this is seemingly complex. It is an electric grenade, so it relies on an electrical power source to function. So first, before we get into anything else, I'm going to show you the diagram for how this grenade works electrically. Alright, so as I said before, this grenade is an electric grenade, meaning that it has a battery, and that's what sets off the detonator. This is schematic for it. So you've got a battery here. It's a thermal battery, which I will explain when we back on the actual picture of the grenade. Then there's an arming switch, and then in normal use, you've got an impact switch, and then it goes to the detonator, which is connected to the ground, completing the circuit. This means that once you pull the pin and throw the grenade, you've got a battery that energizes basically, and that will set the arming switch, and then when it impacts, this closes and fires a grenade. Now, say for whatever reason you threw it and it landed in really soft snow and doesn't explode from the impact. Well, there's a self-destruct switch built into this thing too, and after a certain amount of time, this one closes, bypasses this whole impact switch, and fires the detonator. Keep this in mind, because I will be sort of referencing it, but I'm not going to come back to it as a picture, so at worst, if you need, just come back in the video. So here's the thermal battery I was talking about. It's this whole piece right here. Now, a thermal battery, what it does is that it uses heat to melt a solid electrolyte, and once it's melted, it becomes like a standard battery that you would normally have, like your Duracells, your Energizers, whatever you want to call them. But while it's solid, it doesn't have any electricity flow or electron flow. This means that to start off with, it has a 15-year shelf life according to the documentation. And what would happen is, when it's ready, this swings around, the hammer swings around, hits a primer, or the primer, which ignites. It's almost like a thermite mix, and that heats up the thermal battery until all the electrolyte melts, and then your two electrodes, you have your negative and positive, and it works just like a normal battery. This whole procedure, if I'm not mistaken, takes about 0.5 seconds to get a battery that's actually fully functioning. So that adds a part of the delay in arming here. Now your next part, it's hard to see in this picture, but it's about right here. This here is the arming switch. So I'm going to take you to a somewhat picture of this. It's not quite the same, but you'll get the gist of it. There is slight differences between the actual grenade here, the cutaway, and the documentation I've seen. I don't know if it's just because the grenade wasn't assembled properly by whoever did the cutaway, or if they just changed their method of manufacturing between this grenade here and when they talked about it, when they explained how it worked. So now we're going to go into that arming switch. So here is the arming switch that I was talking about. It's called a fusible link switch, and what it does is it uses the heat source from the thermal battery that you just saw to melt, see the alloy that's here, eutectic alloys. Well, in this case it's a cadmium lead zinc blend or mix or whatever with a, according to documentation, 280 degree Fahrenheit melting temperature. So when the thermal battery is heated up, it melts the alloy, and the alloy is able to flow through the insulator that's here and connect the two parts together, as you see here. So now this is connected to this, even though the insulator is here. So that's your first step. That is what finally gets the grenade armed. And this melting procedure, or melting step, takes about 1.5 seconds to do. So now you've got your 0.5 seconds from your battery to get to its proper voltage, and a 1.5 second delay before this is armed. This obviously gives you a good standoff before it actually arms itself, the grenade. So you don't have to worry about basically throwing it in and hitting something and blowing up right next to you. So now you see that's basically just set up the grenade. We'll go back to the grenade again and we'll follow down in the regular use here. Now you see the battery charges itself, and that little arming switch that's here, once it heats up enough, that 1.5 seconds, connects basically the positive side. So if you follow the grenade, I'll try to move it for us. You've got the ground of the grenade is traveling right along through the metal parts on the side, and you see that that's insulated by a bunch of different spacers, I guess you would call them. So now the whole outside of this thing, all the way here, is all negative. And you just armed here, so now you've made this positive, and it travels through here and connects to this switch here. This switch here, it's a pretty interesting little switch. What it's made up of is two connections right here. So this one here is live at the point that we've got the armed grenade, but it can't connect here because there's nothing connecting the two. So what you need is a switch of sorts, and this is where this is the actual impact switch here. So these are little balls, weighted balls. There's 8 of them in total, facing different directions and that, so that depending on how your grenade lands, one will always set it off, or should at least almost always set them off. They're called always fuses because it doesn't matter which way the grenade lands, it's supposed to go off. And you'll see this little piece of metal here that isn't connected to this. Well, that's a piece of spring steel. So it holds in position until it hits something. Then as it hits something, the ball pushes up against it, and this pushes up against this terminal here, which completes a circuit. And since you see there's an area where they could actually flex, the ball will continue moving into it, which will flex the spring steel even after it's touched here, which gives it more time to actually have the current run through it. I'll show you a picture of, like a black and white picture of it that's all labeled now, and we'll go through the arming of it. This is a drawing of what you just saw in the cutaway. The balls are here once again. You've got the little metal strips here. In the cutaway of the grenade, you don't see this, and you don't see this. Now either they accidentally cut it off when they were doing the grenade, or as I said before, maybe it's a slight modification on the grenade afterwards. But that's how on this end is the end that's connected to the top part of the grenade that you saw before, the top part of the fuse. So there's a piece of metal that's here that the current is flowing through, and this connects to it because you saw there's a bar that goes down the middle here. That I'll get to later. So anyways, there's a contact here, and the power goes, well, the electricity could only go here. There's no connection to the ground, which would be on this side, so it's unable to do anything. Once the target hits the ball here, or one of the 8 balls will hit their respective little piece of sheet metal, bend it inwards, and it'll touch on this, making the connection between the two. So this closes it, and as I said before, the ball, because of its momentum basically, will continue pushing and bending the actual piece of spring steel, so that the connection lasts much longer than if it were just to hit a solid switch and bounce off. So it increases the likelihood that it will actually detonate have enough current going through to detonate the electric blasting cap or electric detonator. Anyways, so the connection then goes through here, and this is what's connected to the detonator. So that's how the switch works. Very basic, very simple. Just it must be expensive to build one of these things. That whole grenade the whole fuse must be expensive. Anyways, we'll go to the next part now, which is technically the detonator, but I'm not going to talk too much about that. I'm just going to show how it's connected to it, and then we'll continue from there. I think that right there in the background is a connector that we saw in the picture. They cut it in the opposite way, so instead of cutting it through the connector, they cut one connector right off, I believe. And you would have the same thing on that side. I think right here alongside is a piece that you see in the bottom portion. So that means the other one's cut off too. Anyways, so what happens is now, once that closes the circuit there, as you saw in the actual diagram of it, the electric blasting cap now has positive coming through here, and the ground able to travel through here. Now, just like any igniter, if you have a rocket, whatever, this explodes, or this ignites it, explodes, and sets off the booster here, which then sets off the grenade. Now, before I mentioned the grenade has a self-destruct on it, and I said I'd ignore this part before from the other picture, and I'll talk about it now. This whole piece here is actually the self-destruct mechanism on it, and it's a pretty smart little device. It gives you 4.5 seconds after the grenade is armed, or after this spoon comes off the grenade, or the lever comes off the grenade, for it to be gotten rid of. This means that if it landed in soft snow, or for some reason the impact, or tremble, I think it is called, what they call tremble switches, or anyways, the impact switch here fails for whatever reason, you're not going to have a grenade sitting around. It'll still be useful to the person who threw it, because it will still explode. And some kid's not going to find it 10 years later or a few months later and end up hurting themselves with it. Alright, so here is the switch. As I said, it's a little bit different from the one on the grenade there, but this is its open position. This is right at the beginning, before you started up the grenade, before you pulled the pin on it and fired it and threw it. So this is how it would be. What happens is your battery, which is up here, as you saw in the other picture, heats up. Once it heats up to, it's about 490 some odd degrees Fahrenheit, or about 500 degrees Fahrenheit. The black thing that you see here is a pellet of mercuric iodide, or mercury 2 iodide. So this stuff here acts like a really high resistor, high strength resistor, and it prevents contact between the part here, which after the grenade has been armed is live basically, and this part here, which would be technically the negative, or the ground on it. So right now that's holding it open. As the temperature reaches about 500 degrees and basically 4.5 seconds, all this melts away and you've got it in its closed position now, allowing current to flow through this. Interesting, works sort of like that fusible one that we saw before, except the other one, the temperature sensitive alloy conducts electricity, so you couldn't use it in this one here because it would be setting off the grenade right away as soon as the battery got voltage to it and the arming switch went. So after 1.5 seconds, the grenade would explode directly. So this, they had to use the mercury 2 iodide. It melts away, letting the spring push the metal up against it, and that completes a circuit, just like hitting the switch on a light basically. So as I said, that's 4.5 seconds after the battery has heated up, started heating up. So we'll go back to the grenade and we'll finish up with this. Alright, so as you see, right here's a spring. It's been nicely cut, so. And for some reason in the actual drawing, this whole thing moves up with the spring 1/8 of an inch. In this case, you can see that the spring is what's going to act like a conductor, and that's going to be pushing this ring up to the top. Right here in the space is that pellet of mercuric iodide or mercury 2 iodide that will melt away, allowing this to be touching up on here. There it goes. Then the current could start going through here and either directly touch here in this picture, or in the other one this would touch here somewhere and do the same idea. It would still set off this. So as you see, it bypasses. It's a smart way to bypass the actual impact switch, and then it detonates, sets off the electric detonator, which sets off the grenade again. So we'll zoom out of this and we'll go through it quickly once. So person pulls the pin, throws a grenade. The spoon comes off, the striker hits the primer. Primer ignites the mixture in here, which is a thermite style mixture, which provides the heat to melt the electrolyte, which causes the battery to actually become a battery rather than just a solid piece. Now that powers up. You've got the negative side going, or the ground has now become the whole case around it. So that's got the ground here, and the heat from the battery sets your first thermal switch, so your arming switch is now set, and by that time it's flown for 1.5 seconds, and as soon as it hits an object, one of the balls, or more than one of the balls, will force on this, connecting these two once again, which connects power, well, connects to this part of the detonator, causing it to explode, setting off the booster, which then sets off the grenade. There's supposed to be a 35-gram minimum to set these things off, which would prevent it from going off if you decide to throw the grenade and it was ready to be thrown, basically. So it was all armed. If you threw it, technically it shouldn't explode, but I wouldn't take my chances with that anyway. And it won't explode if it hits small branches along its way. So if you're in cover, or if you threw it through a window or something, it wouldn't explode from that. It would only explode when the grenade finally hit something solid. So it's got that, but because it is sensitive to go off with almost anything, but in the manual it does say deep snow, deep soft snow will cause it to fail. So if that fails for whatever reason, like I said, the grenade will not stay there without exploding. What happens is that right from the beginning, the heat that was being created here, or the heat from this, was melting that little fusible link there, which after 4.5 seconds connects to here, connects these two parts here. Now that means current is able to flow through there, which flows through here, and once again right back to the detonator, exploding the grenade. So that is how these grenades work. Anyways, hope you enjoyed this, hope it explained this grenade, and hope it'll take a lot of the mystery away from how they work. Thanks for watching. Obviously you know how YouTube works. If you like it, hit the like button. Sub if you like these kind of videos and you want to see more. I do a lot of how-to videos for guns too, or how they work videos for guns. And if you don't like this video, feel free also to not like it, but please write a comment at the bottom telling me what I did wrong, and I'll try to work on it for my next video. So thanks again for watching. Any questions, please leave them in the comments, and hopefully I'll have another video out soon.